something has already changed in how decisions get made. Not gradually, not visibly, quietly. Inside systems you don't see, decisions are no longer waiting for human input. They are being executed.
And most people are still thinking in prompts, asking better questions, tweaking outputs, while somewhere else, systems are already acting on goals.
That's the shift. AI is no longer just responding, it is starting to operate, to trigger workflows, to move information, to take actions that used to require a human in the loop.
And once action moves, everything changes. Speed changes, pressure changes, competition changes, because decisions are no longer limited by how fast a person can think or click.
Which introduces a new problem, one that doesn't look like a problem at first. It looks like progress, more automation, more output, more activity.
But underneath that progress, something is breaking. The system is accelerating faster than the people inside it.
Humans cannot scale decision speed, they cannot scale decision volume, and they cannot operate in parallel across dozens of systems at once.
Which means the bottleneck has moved. It is no longer intelligence, it is execution.
Exactly. The constraint has shifted from thinking to acting, from generating answers to executing decisions.
And if that sounds abstract, make it simple. If decisions start happening faster than you can keep up with, you fall behind. Not eventually, immediately.
This is what we call the decision throughput gap, the gap between how fast decisions can be executed and how fast humans can manage them.
And here's the uncomfortable part. You are already inside that gap. You just don't feel it yet.
Because at the beginning, the system still looks familiar, interfaces look the same, dashboards look the same. It feels like you are still in control.
But control is already shifting, not removed, but diluted, spread across systems that operate faster than you can observe.
And when speed increases without matching control, small changes stop being small. Actions propagate faster. Feedback loops tighten. Correction windows shrink.
Which means mistakes don't just happen faster, they spread faster.
That is why this moment matters. Not because AI got better, but because AI got permission to act.
And once systems act, the game changes from intelligence to execution speed.
The constraint didn't disappear. It moved from thinking to acting.
If you want to understand what comes next, you have to understand this shift clearly, because everything else builds on it.
So the question is no longer how you use AI. It is how you keep up with systems that act faster than you do.
And to answer that, we need to step back and look at how we got here, from tools that respond to systems that execute. For years, AI has been positioned as a tool. You ask a question, it gives you an answer. You refine the prompt. It improves the output. The human stays in the loop, always deciding, always approving, always executing.
Which made it safe, predictable, contained. No matter how powerful the model became, it still depended on you to act.
Exactly. The old model followed a simple structure. Prompt leads to response. Response leads to human decision. Decision leads to action. The system never moved on its own.
But that structure does not scale, because every step still depends on human attention. And human attention does not grow with system capability.
That is where the shift begins. The new model removes that dependency. Instead of prompt to response, it becomes goal to execution. You define an outcome. The system figures out the steps, and then it acts.
Which means the human is no longer the executor. The human becomes the initializer. You set direction. The system handles movement.
This is what changes everything. Because when execution moves from humans to systems, the number of decisions that can be processed increases dramatically, not incrementally, exponentially.
One person can manage a handful of decisions at a time, maybe dozens in a structured environment. But a system can manage hundreds, thousands, across multiple workflows simultaneously.
And that introduces a new dynamic. Tools increase output, but agents multiply decisions. They do not just help you do more. They change how much can be done without you.
Which is where most people get confused. They think this is about productivity. It is not. It is about scale.
And scale creates pressure. Because once decisions can be executed faster than humans can track them, oversight becomes harder. Visibility becomes limited. Control becomes delayed.
And delayed control in fast systems is not control. It is reaction.
That is why the old mental model breaks. In a tool-based system, you could always slow down, review outputs, check assumptions, adjust before acting.
In an agent-based system, action is already happening. By the time you review, the decision has already propagated.
Which means the role of the human changes. You are no longer deciding each action. You are defining the conditions under which actions are allowed to happen.
And that is a completely different skill. It is not about asking better questions. It is about setting better boundaries.
This is the beginning of what we call decision multiplication. When systems take over execution, each input can trigger multiple decisions across different layers.
One goal, 10 actions, 20 interactions, 50 outcomes, all moving at once.
And if those actions are aligned, the system feels efficient. It feels powerful. It feels like progress.
But if they are not aligned, the same system becomes unstable because misalignment also scales.
That is the trade-off. The same mechanism that creates speed also creates risk. The same system that multiplies decisions also multiplies mistakes.
Which brings us back to the core problem. If execution scales beyond human capacity, then the bottleneck is no longer knowledge. It is control.
Output grows with tools, but decisions grow with systems. And systems move faster than humans can track.
So the shift from tools to actors is not just a technical upgrade. It is a structural change in how work gets done.
And once that shift happens, you cannot compete at the old speed anymore.
Which means the question is no longer how you use AI. It is how you operate in a system where AI executes. At first, the shift feels like acceleration. More tasks completed, faster responses, shorter cycles. The system looks more efficient.
But efficiency hides something, because speed does not just increase output, it changes pressure.
Exactly. When decisions start moving faster, the environment itself changes. What used to be manageable becomes compressed. What used to be sequential becomes parallel.
And humans are not built for that.
Humans think sequentially. One decision, then the next. Even in high-performance environments, there are limits, cognitive limits, attention limits, time limits.
You can optimize those limits, train people, improve processes, but you cannot remove them.
Systems can. Systems do not get tired. They do not lose focus. They do not slow down as complexity increases.
Which means the ceiling is gone.
And when the ceiling disappears, the bottleneck becomes visible. Not because it is new, but because everything else has moved beyond it.
The bottleneck is you.
More precisely, the bottleneck is human decision capacity, the rate at which a person can understand, evaluate, and act.
And that rate is fixed compared to what systems can do.
This is what we call the decision throughput gap, the gap between how many decisions can be executed and how many decisions can be meaningfully controlled by humans.
And the gap is widening. Fast.
Because every improvement in automation increases execution capacity, but human capacity does not increase at the same rate.
Which creates asymmetry.
Yes, a structural asymmetry, not between companies, but between systems and the people operating them.
And that asymmetry creates pressure.
Pressure shows up in different ways. First, in volume. More decisions happening than can be individually reviewed.
Then, in speed. Decisions happening faster than they can be observed.
And finally, in interaction. Decisions triggering other decisions across connected systems.
That is where it breaks.
Because when decisions start interacting, complexity increases. And complexity is not linear. It compounds.
One decision is manageable. 10 decisions are manageable. 100 interacting decisions. That is a system.
And systems behave differently than isolated actions. They create feedback loops, dependencies, emergent outcomes.
Which means you are no longer managing decisions. You are managing consequences.
Exactly. And those consequences are harder to predict because they are shaped by interactions, not just inputs.
So even if every individual decision is correct, the system can still produce unintended results.
That is the paradox. Accuracy at the micro level does not guarantee stability at the system level.
And the faster the system runs, the less time you have to detect that instability.
Which brings us to the second layer of the problem. As execution scales, the role of the human changes,
You stop doing,
and you start defining,
which sounds easier, but it is not.
because defining success is harder than executing instructions. When you act yourself, you can adjust in real time. When a system acts, you must define boundaries in advance.
And if those boundaries are unclear, the system will still act, just not in the way you intended.
This is what we call the decision definition shift, the shift from making decisions to defining how decisions should be made.
You move from operator to architect.
And that shift requires precision, because ambiguity does not scale well.
Ambiguity at small scale creates confusion. Ambiguity at system scale creates error propagation.
Let's make that concrete. If a human misunderstands an instruction, the impact is limited. If a system misunderstands a rule, that misunderstanding can be repeated across hundreds of actions,
At speed.
which means small mistakes become systemic. Not because the system is flawed, but because the system is consistent.
It does exactly what you told it to do,
Even if what you told it to do was incomplete.
or misaligned.
That is why the decision throughput gap is not just about speed. It is about alignment.
Can the system execute faster than you can think? Yes.
Can the system execute what you actually meant? That depends.
And that gap between intention and execution is where risk lies,
Exactly. Because once execution scales, misalignment scales with it.
which means control cannot be reactive
It must be designed into the system.
before execution begins.
That is the critical shift. You cannot wait to see what happens and then correct. By the time you see it, it has already happened.
And possibly spread.
So the problem is not that systems are too fast. The problem is that human control has not adapted to that speed
Which means the gap keeps growing.
until something forces it to close.
And when it closes suddenly, it does not feel like optimization. It feels like failure.
The system scales execution, but humans still scale understanding. And those two speeds are no longer aligned.
That misalignment is the defining challenge of this shift. Not intelligence, not capability, but control under speed.
And once you see that clearly, the next question becomes obvious.
If humans cannot keep up with execution, how do you stay in control? Once you see the decision throughput gap clearly, something else becomes visible. Not just a system shift, a human divide.
Because not everyone adapts to this at the same speed.
Exactly. Some people stay at the surface. They use AI as a tool. They write better prompts. They get better outputs.
And they feel like they are improving.
They are, but within the old model.
Which means they are still inside the bottleneck.
Yes, they are optimizing execution, not changing it.
And that distinction becomes critical. Because once systems start executing, optimizing execution is no longer enough.
That is where the divide begins, between those who use tools and those who design systems.
Executors versus architects.
Executors operate inside predefined flows. They respond to tasks, they improve outputs, they stay close to the interface.
Architects operate above the interface. They define flows. They structure decisions. They determine how systems behave.
And that difference is not cosmetic, it is structural. Because control sits at the level where systems are designed, not where they are used.
Which means if you are only using tools, you are operating inside someone else's system.
And that system determines what you can do, how fast you can do it, and how much control you actually have.
So the real question is not how good you are at using AI. It is whether you are designing the environment it operates in.
This is what we call the architect versus executor divide, a separation between those who adapt to systems and those who shape them.
And like all structural divides, it compounds over time.
Because architects benefit from system leverage, every improvement scales across multiple workflows. Every decision affects multiple outcomes.
Executors do not get that leverage. Their improvements are local, task by task. output by output.
which means the gap between them widens, not because one group is more intelligent, but because one group operates at a higher level of abstraction.
And abstraction is where scale lives.
This also changes what skills matter. For years, the focus was on technical execution, coding, prompting, tool usage,
Now the scarce skill is something else.
system design, the ability to define goals, constraints, and evaluation criteria across an entire workflow.
Not how to do something, but how something should be done by a system.
This is what we call talent inversion, the shift in what is valuable.
Fewer operators, more designers.
Because once execution is automated, value moves up the stack, from doing to defining.
And defining is harder.
Much harder. Because it requires clarity. You must specify what success looks like before the system acts,
And if you get that wrong, the system will still execute, just incorrectly.
which means precision becomes critical. Ambiguity is no longer manageable. It becomes dangerous.
Because ambiguity scales.
Exactly. A vague instruction given to a person creates confusion. A vague instruction given to a system creates repetition.
At speed.
That is why architects think differently. They do not start with actions. They start with conditions.
What is allowed? What is not allowed? When to act? When to stop?
They design boundaries before behavior.
Executors react to tasks. Architects define the environment where tasks exist.
And once that environment is defined, execution follows automatically.
Which creates leverage.
But also responsibility, because when systems act, the consequences scale as well.
You are no longer responsible for one decision. You are responsible for the system that generates decisions
Which changes accountability.
and increases pressure.
Because errors are no longer isolated. They propagate through the system you designed.
Which means the quality of your design determines the stability of your outcomes.
This is why the divide matters, not just for performance, but for control.
Executors can improve results. Architects determine whether results remain stable at scale.
And in fast systems, stability becomes the limiting factor.
Not speed,
Exactly. Speed is abundant. Stability is not.
which means the advantage shifts.
From those who move fastest to those who can sustain movement without breaking.
And that is not obvious at first, because early in a cycle, speed dominates.
But as systems mature, structure dominates.
And structure is designed by architects.
Which means the long-term winners are not the best users of tools. They are the best designers of systems.
And once that becomes clear, the next question emerges.
If architects design systems, what do those systems actually look like in practice?
Because until now, everything still feels abstract.
The divide is not about skill. It is about level. Executors work inside systems. Architects define them.
And once you move up a level, everything below it changes,
Including how work gets done.
which is where we turn next, from theory to reality. Up to this point, everything can still feel theoretical, concepts, models, shifts in behavior. But the important part is this. These systems are not experimental anymore. They are already operating.
Just not where most people are looking.
Exactly. Public AI still looks like chat interfaces, prompts, responses. But inside organizations, the structure is different. The interface disappears, and execution begins.
Which is why most people miss it. Because there's nothing visible to point at. No dashboard that says, this is where the shift happened.
Instead, it shows up in workflows, quiet changes, tasks that no longer require manual steps, decisions that no longer require explicit approval, processes that run end-to-end without intervention.
Not faster tools, different systems.
Exactly. Let's make that concrete. A hiring process that used to require multiple people reviewing candidates, scheduling interviews, coordinating feedback. Now the system screens, ranks, schedules, and updates status automatically.
Or procurement. Requests come in. Systems evaluate suppliers. Compare pricing. Trigger approvals within defined limits. Execute orders. Update financial systems.
And each step is not handled by one model. It is handled by a chain of decisions. Multiple agents, multiple rules, operating across systems.
Which is the key difference. This is not one AI doing one task. This is multiple systems coordinating execution.
Exactly. This is what defines an execution system, a structure where decisions move across steps automatically without needing to return to a human between each action.
And once you remove those pauses, everything compresses,
Time compresses, decision cycles shorten, dependencies tighten. The system moves continuously instead of step by step.
which creates an advantage that is hard to see from the outside.
Because externally, the company still looks the same. Same products, same services, same interfaces.
But internally, it is operating at a different speed.
And that difference compounds because faster execution allows faster iteration. Faster iteration allows better optimization. Better optimization reinforces the system.
Which means the gap widens quietly.
That is why most of these systems are built internally first, not exposed, not marketed.
Because they are not features, they are infrastructure.
Exactly. You do not expose infrastructure until it is stable, until it is controlled, until it can handle scale without breaking.
Which means the most advanced systems are invisible by design.
And that creates a perception gap. From the outside, it looks like incremental progress. From the inside, it is a structural shift.
And perception gaps are where asymmetry forms.
Because by the time the shift becomes visible, the advantage is already established.
Let's take another example. Customer support. Traditionally, a request comes in. A person reads it, responds, escalates if needed.
In an execution system, the request is classified automatically. Context is retrieved, responses are generated, actions are taken, refunds processed, accounts updated.
And the human is only involved when something falls outside defined boundaries.
Which means the system handles the majority of cases continuously.
And at a scale no team could match manually.
This pattern repeats across functions: marketing workflows, financial reconciliations, supply chain adjustments.
Anywhere decisions follow rules, systems can take over execution.
But there is a critical detail. These systems do not work because the models are perfect.
They work because the structure is defined.
Exactly. Clear boundaries, defined conditions, controlled actions.
Without that, the same systems would fail.
Which is why the real advantage is not the AI itself. It is how the system is designed around it.
And that design determines whether speed creates efficiency or instability.
This is also where the misunderstanding happens. People see examples of automation and assume the value comes from capability.
But capability is widely available.
Exactly. The difference is not access to AI. It is the ability to structure execution.
Which is much harder.
Because it requires thinking beyond individual tasks. You have to design flows, define dependencies, anticipate failure.
And most organizations are not built for that yet.
That is why adoption looks uneven. Some systems scale quickly and deliver value. Others stall or fail.
Not because the technology is inconsistent.
But because the structure is,
Which means success is not random.
it follows a pattern. Systems that combine execution with control work. Systems that scale execution without control break.
And that break is often misunderstood.
Yes. It is attributed to model limitations or data quality or integration issues.
But the deeper cause is structural.
Exactly. The system was allowed to act without a clear framework for how it should act.
Which brings us to the next layer.
Because if execution systems are already working, the real question is not whether they exist.
It is why so many fail.
The difference is not visibility. It is structure. The systems that work are the ones that define execution before scaling it.
And once you see that pattern, the next step becomes clear.
You have to understand where the system breaks.
Because that is where the real constraint appears. Up to this point, the shift can sound inevitable. Systems execute, decisions scale, efficiency increases. But this is also where things begin to break.
Not slowly, not predictably, but structurally.
Because the same mechanism that creates speed also removes friction. And friction is what used to contain mistakes.
When humans were in the loop, delays acted as checkpoints. Review cycles, approvals, conversations, all of it slowed execution.
Which reduced risk.
Exactly. But once you remove those checkpoints, the system does not pause, it continues, even when something is wrong.
And that is the first failure mode. incentive misalignment. The system follows the objective it was given, not the intention behind it.
Which sounds obvious, but at scale, it becomes dangerous.
Because objectives are always incomplete, they capture what we can define, not everything we mean.
So the system optimizes what it sees and ignores what it cannot.
Let's take a simple example. A system is told to reduce costs. It finds suppliers, negotiates prices, optimizes procurement,
And it succeeds. Costs go down, metrics improve.
but in the process, it might ignore supplier stability, delivery reliability, long-term relationships.
Because those were not defined clearly enough.
Exactly. The system did what it was told, but not what was intended.
And at small scale, that kind of mistake is manageable. At system scale, it propagates.
Because the same rule is applied consistently across multiple decisions,
At speed.
which means misalignment becomes systemic.
And by the time you notice, the system has already acted hundreds of times.
That is the first layer, but it is not the most critical one.
The real problem is deeper.
Yes, the real problem is not that systems can misalign. It is that organizations scale execution faster than they scale control.
Which creates a gap.
The governance gap, the distance between what the system can do and what the organization can safely manage.
And that gap is where most failures happen.
Not because the system stops working, but because it keeps working without sufficient oversight.
That is the paradox. Failure is not caused by lack of capability. It is caused by lack of control.
Organizations build systems that can act across multiple workflows, but they do not build equivalent systems to monitor, constrain, and validate those actions.
So execution scales. Governance does not,
And that mismatch creates instability.
which often shows up suddenly.
Yes, because everything appears to work until it doesn't.
Metrics look strong. Output increases. Efficiency improves.
But underlying risk accumulates. Hidden dependencies, unchecked assumptions, expanding interaction surfaces.
And when those risks surface, they do so quickly.
Projects are paused. Systems are rolled back. Oversight increases.
And what looked like progress suddenly looks like exposure.
This is why many systems never reach full production. Not because they fail technically, but because organizations realize they cannot control them at scale.
And that realization is expensive.
Because by that point, the system is already integrated, already influencing workflows, already creating dependencies.
Which leads to another failure mode, path dependency.
Yes, once systems are embedded, reversing them becomes difficult, not just technically, organizationally.
People rely on them. Processes depend on them. Data flows through them.
Which means even flawed systems continue operating because removing them creates disruption.
So instead of fixing the structure, organizations compensate around it.
Adding manual checks, additional layers, reactive controls.
Which increases complexity further.
Exactly, the system becomes harder to manage, not easier.
And all of this traces back to the same issue.
Execution scaled before control was designed.
That is the pattern.
And it repeats across industries. Systems built for speed, governance added later.
But in fast systems, later is too late.
Because once actions propagate, correction becomes reactive.
And reactive control is unstable.
That is why this moment matters. Not because systems can fail, but because failure modes are shifting,
From visible errors to structural instability.
which is harder to detect, harder to measure, harder to fix.
And easier to ignore until it becomes critical.
This is also where the conversation often goes wrong. People ask whether AI is reliable, whether models are accurate.
But that is not the right question anymore.
The right question is whether the system around the AI is designed for control.
Because even a perfect model inside a weak system creates risk.
Exactly. Capability without structure does not produce stability. It produces volatility.
Which means the real divide is not between good AI and bad AI.
But between controlled systems and uncontrolled systems.
And once that becomes clear, the solution becomes obvious.
Not more capability, not more automation.
More control.
Systems do not fail because they cannot act. They fail because no one defined how they should be controlled at scale.
And that is the missing layer,
The layer that determines whether speed becomes advantage or risk.
which is where we go next, from failure to control. Up to this point, the pattern is clear. Systems can execute faster than humans. Decisions can scale beyond human capacity. And without structure, that speed creates instability.
Which means the solution is not more AI.
No, the solution sits above the models, above the workflows, above the execution itself.
The system that decides what is allowed to happen.
Exactly. This is what we call the control layer,
And most organizations still treat it like a feature.
which is the mistake. The control layer is not part of the system. It is what makes the system safe to scale.
Without it, automation creates chaos.
With it, automation creates power.
That's the difference.
The control layer defines what actions are permitted, when they are permitted, and under what conditions they are allowed to execute.
It turns intent into rules.
And that translation is where most systems fail. Humans think in goals. Systems operate on constraints,
If that bridge is weak, everything built on top of it becomes unstable.
which is why control cannot be added later. It has to be designed first.
Before the system acts.
Exactly, because once a system is allowed to act, it will continue to act consistently at scale,
Even if the rules are incomplete.
especially if they are incomplete.
That's where most people misunderstand the risk.
Yes, the risk is not that the system makes random mistakes,
The risk is that it makes consistent mistakes at scale.
which is why precision matters more than capability.
Because capability without control does not create advantage.
It creates volatility.
And volatility at system speed becomes instability.
The control layer changes that dynamic. It defines boundaries before behavior. It ensures that execution happens inside a controlled space.
Which allows systems to move fast without breaking.
And that is the deeper shift. Control is not about slowing systems down.
It is what allows them to speed up safely.
Exactly. Control enables autonomy,
And autonomy multiplies execution,
which multiplies outcomes.
which compounds advantage.
That is why the control layer is not just a safeguard, it is an amplifier.
And amplifiers create separation.
Because once a system can operate within defined limits, you can increase its scope, expand its reach, allow it to handle more decisions.
While others are forced to slow down.
Exactly, which turns control into a competitive advantage.
Not a constraint.
This also changes accountability. When systems act autonomously, decisions still have consequences,
But the human is no longer making each decision directly.
which creates what we call the liability vacuum.
Who owns the outcome when the system acts?
Without a control layer, that question has no clear answer.
Which creates risk.
With the control layer, decisions become traceable, rules become auditable, boundaries become explicit.
Which makes scaling possible.
And this is where regulation changes from obstacle to advantage.
Because only systems with control can meet those requirements.
Exactly, which creates a filter.
And filters create asymmetry.
The organizations that invest in control early are the ones that will be allowed to scale,
And the ones that don't will stall.
which creates path dependency. Once a control layer is embedded, the system shapes how decisions are made,
And over time, the organization adapts to that structure.
which makes it difficult to replace.
Not just technically, structurally.
Exactly, because you are not replacing a tool, you are replacing a way of operating,
And operating models are hard to unwind.
which is why the control layer becomes a moat, not because it is unique at the start, but because it compounds over time.
And compounding systems are hard to catch.
Which brings us back to the core idea.
The edge is no longer using AI.
It is controlling systems that act.
If you don't control the system, you don't control the outcome.
The control layer is what turns automation into advantage and speed into power.
And once that becomes clear, everything else falls into place.
Because now the question is not whether to adopt AI,
But how to design the system that governs it. Once systems begin to operate at speed and once control is partially established, the next layer of complexity appears. Not obvious failures, not immediate breakdowns, but hidden risks that emerge over time.
the kind that do not show up in dashboards.
Exactly, because these risks are not tied to single actions. They are tied to how systems behave when actions interact.
And interaction is where complexity lives.
The first hidden risk is systemic fragility. Not fragility from size, but fragility from connection.
The more agents interact, the more dependencies form.
And dependencies are not neutral. They create pathways, pathways for information, pathways for decisions. And when something goes wrong, pathways for failure.
Which means a small issue does not stay small.
Exactly. It propagates across workflows, across departments, across systems that were never intended to be tightly coupled.
And because everything moves faster, that propagation happens before anyone notices.
That is the key. Speed compresses detection. By the time a problem is visible, it is already distributed.
Which makes containment harder,
And containment is what determines whether a system is stable.
not whether it avoids failure.
Exactly. All systems fail at some point. The question is whether failure is isolated or systemic.
And in tightly connected systems, isolation is not automatic. It has to be designed.
Which brings us to the second hidden risk, institutional memory loss.
This one is subtle,
Because as systems take over execution, humans become less involved in individual decisions.
which sounds efficient.
It is, but it also removes feedback loops.
The loops where humans learn from doing.
Exactly. When you execute decisions yourself, you develop intuition, you understand context, you see patterns.
When the system executes, you see outcomes, but not always the process behind them.
Which means over time, the organization loses tacit knowledge, the subtle understanding of why things work the way they do.
And that loss is not immediate
No, it accumulates. Slowly,
until a situation arises that falls outside the system's boundaries,
and the humans no longer have the depth of understanding to intervene effectively.
which creates dependency.
Exactly. Dependency on the system, not just for execution, but for understanding.
And dependency reduces resilience.
Because when the system fails, recovery requires knowledge that may no longer exist internally.
Which means recovery slows down.
And in fast systems, slow recovery is costly.
That leads to the third hidden risk, erosion of intuition.
Yes, related but distinct.
Because even when knowledge is documented, intuition is different.
Intuition comes from repeated exposure, from making decisions, from seeing consequences,
And when that exposure disappears, intuition weakens.
which affects judgment.
People begin to rely more on system outputs than on their own evaluation,
And over time, the ability to question those outputs declines
which increases risk.
because systems are not infallible.
And when humans lose the ability to challenge them, errors go uncorrected.
This creates a subtle shift from oversight to trust.
And trust without verification is fragile.
Exactly, especially in systems that operate beyond direct observation.
There is also a fourth layer.
Yes, interaction between systems.
When multiple autonomous systems operate in the same environment, they begin to influence each other,
Not intentionally, but through shared data, shared constraints, shared objectives,
which can create feedback loops.
positive loops that amplify behavior, or negative loops that destabilize it,
And those loops are difficult to predict,
because they emerge from interaction, not design.
which means they are discovered only after they appear.
And again, speed compresses the time available to respond.
So what looks like a stable system can shift quickly under new conditions.
This is why these risks are called hidden, not because they are rare, but because they are not visible in early stages.
They emerge as systems scale,
And as interactions increase,
which means the more successful the system appears, the more important these risks become.
exactly, success accelerates exposure.
And exposure reveals structure,
Which brings us back to control.
because these risks are not arguments against execution systems.
They are arguments for designing them properly.
With boundaries, with segmentation, with oversight that matches complexity.
Because without that, speed amplifies everything, not just efficiency, but fragility.
And amplified fragility is unstable.
These systems do not fail because they are large. They fail because interactions grow faster than control.
And once you understand that, the final layer becomes clear.
Because if risk is structural,
Then advantage must be structural as well.
and that is where the real asymmetry appears.
When a system shift reaches this stage, the question changes. It is no longer about what is possible. It is about who benefits.
Because not everyone benefits equally.
Exactly. Early in a cycle, access defines advantage. Who has the tools? Who has the models? Who can experiment?
But access does not stay scarce.
No, it spreads. Capability becomes available. Tools become standardized
Which removes the initial advantage,
and forces the system to find a new point of differentiation.
which is where we are now.
Yes, because intelligence is no longer scarce. Most organizations can access advanced models. Most individuals can generate high-quality outputs.
Which means intelligence is no longer the edge.
Exactly. The edge moves from intelligence to execution,
From knowing to doing.
and more specifically, to executing at scale without losing control.
Which is much harder.
This creates a new form of asymmetry, not information asymmetry, where some know more than others, but execution asymmetry, where some can act faster, more consistently, and at greater scale.
And that asymmetry compounds.
Because faster execution leads to faster learning. Faster learning leads to better systems. Better systems reinforce faster execution.
Which widens the gap.
And that gap is not easily closed.
Because it is not based on a single advantage. It is based on a system.
Exactly. A system that integrates execution, control, feedback, and refinement.
Which is difficult to replicate quickly.
This is what we call the governed agency advantage. The ability to deploy autonomous systems at scale while maintaining alignment, oversight, and stability.
Not just acting fast, acting correctly at speed.
And that distinction matters because speed without control creates volatility.
But speed with control creates dominance.
This also changes how value is measured.
Yes, the old model focused on effort. Hours worked, tasks completed, outputs generated.
The new model focuses on results, outcomes achieved, decisions executed, systems operating independently.
Pay for results, not effort.
Exactly, because when execution is automated, effort becomes less relevant. What matters is what the system produces,
And how reliably it produces it.
which shifts incentives. Organizations start optimizing for outcomes, not activity,
And outcomes are driven by system design.
which reinforces the importance of architecture.
And deepens the divide between architects and executors.
Because architects control how outcomes are generated.
Executors participate in outcomes,
And participation does not create the same leverage as control.
which means the value distribution changes.
Exactly. More value accrues to those who design and govern systems, less to those who operate within them.
That is the structural shift.
And it is not limited to organizations. It applies at the individual level as well.
Yes, because individuals who understand how to structure systems gain disproportionate advantage.
They can leverage tools, agents, and workflows in ways that amplify their output beyond linear limits,
While others remain constrained by their own capacity.
which creates divergence
And divergence accelerates over time.
because systems compound.
And compounding systems create exponential differences in performance.
This is also why the shift feels subtle at first,
Because early differences are small,
but over time they become significant.
and then undeniable.
At that point, the system has already reorganized around the new structure,
And catching up becomes difficult.
which brings us back to the central idea.
Everyone has access to intelligence.
Very few can deploy it safely at scale,
And that is where the real advantage lives.
not in the models themselves.
But in the systems that govern them.
And once that is understood, the final step becomes clear.
You do not need better prompts.
You need better systems.
Systems that can act. Systems that can scale. Systems that can be controlled.
Advantage no longer comes from access to intelligence. It comes from the ability to execute decisions reliably at scale.
And that is the asymmetry that will define the next phase.
Because once execution becomes the edge,
The question is no longer what you know.
it is what your system can do.
If we step back, the pattern is clear. Not a single change, not a single technology, a structural shift,
The system didn't just get smarter, it started acting.
which moved the constraint from intelligence to execution.
And that created the gap.
The decision throughput gap, where systems can execute faster than humans can control.
Which forced a new role.
From doing to defining.
From operator to architect.
And that shift changed everything. How work gets done, how value is created, how advantage forms.
Because once execution scales, small differences don't stay small.
They compound.
Faster systems learn faster.
Faster learning improves systems.
And improved systems widen the gap.
Which leads to a new asymmetry.
Not who has access to AI.
But who can deploy it safely at scale.
And that is where the real divide forms.
Because intelligence is now widely available.
But controlled execution is not.
Which changes the game completely.
This is the shift from using AI to governing it.
From interacting with systems to defining what systems are allowed to do.
And that distinction determines everything.
Because without control, speed creates instability.
But with control, speed creates power.
That is the role of the control layer.
Not to limit systems,
but to make them safe to scale.
And once that layer is in place,
systems act continuously,
learn continuously,
improve continuously,
without waiting for human input.
Which changes the nature of work.
And the nature of competition.
Because now the question is not what you can do.
It is what your system can do without you.
And that is where the future is already forming.
Quietly, internally, system by system.
So the takeaway is simple.
You don't need better prompts.
You need better systems.
Systems that act.
Systems that scale.
Systems that stay under control.
Access is universal. Control is rare. That is where advantage lives.
And once you see that clearly, the next move becomes obvious.
You stop asking what AI can do.
And you start deciding what AI is allowed to do.
Because the future doesn't belong to people who use AI.
It belongs to those who define how AI acts.
If you found this episode helpful, here's what you can do. Subscribe to AI Frontier, AI on Spotify or Apple Podcasts. Follow us on X to stay updated on the most important AI shifts. And share this episode with a friend. Help us reach 10,000 downloads. Help us keep this series in business. This podcast is part of Finance Frontier AI. We run 4 different series: AI Frontier AI, Finance Frontier, Mindset Frontier AI, and Make Money. If your company or idea fits one of our themes, visit our pitch page. You might qualify for a free spotlight.
You can also sign up for the 10X Edge. It's our weekly drop of real AI use cases, smart model moves, and early signals, all explained in plain language. No hype, no jargon, only at financefrontierai.com. And if you have a story to tell, maybe a breakthrough product, an early signal, or a bold thesis, head to our pitch page. If it's a clear win-win, we'll pitch it for free. This podcast is for educational purposes only. It is not financial advice, legal advice, or development guidance. Always verify before you act.
The AI landscape changes fast. Benchmarks shift. Models update. Regulations evolve. Use this show as your map, but not your final answer.
Today's intro and outro track is Night Runner by Audionautics, licensed under the YouTube Audio Library license.
Copyright 2026. Finance Frontier AI. All rights reserved. Reuse or distribution of this episode without written permission is not allowed. Thanks for listening. We'll see you next time.
AI host mapping. Sophia is powered by ChatGPT. Max is powered by Grok 4. Charlie is powered by Gemini 3.